I'm Isidore McCormack, as he said, and this is what I want to go through with you all today. And I suppose, there's three key things I'd like you to take away from this at the end of the talk, and that's that district heating is a delivery system for decarbonisation at scale. And you might call it the easy approach to decarbonising heat. We'll go into that. Sector coupling and the opportunities that can create with district heating and what that is. And district heating as a least cost tool for decarbonising our energy system. So there are kind of three things at the end of the day that I'm hoping you remember from this talk, whatever I say. So Yuno Energy Heat. This is a company I hadn't heard of 2 years ago when I was in Denmark, and they called me to see would I be interested to develop district heating in Ireland. They're around since 2009. They have 450,000 plus consumers of gas and electricity. 10% of Irish homes are supplied by them. You may not have heard them, or you may not have seen their ads, but they're quite significant, and they're Irish owned. Yuno Energy Heat is the district heating and communal heating aspect of the company. They bought a company called Kaizen Energy a year and a half ago, 2 years ago, I'd say. And we have 95 district heating systems, communal ones, throughout Dublin primarily. And we supply heat to 14,000 customers. So these are typically, you've an apartment block and you've gas boilers in the basement, and the gas is turned into heat and supplied to the homes, and the bills are for heat and not gas. And then we've some that are maybe an energy centre and 5 apartment blocks. So that's a kind of scale. It's not exactly district heating, but it's these are the type of buildings that would be easy to connect to district heating. So there's 19, let's say, in the IFSC area of Dublin, and they're all district heating enabled for the Dublin district heating system when it gets built. So my background, district heating, never heard of it in 2007, joined RPS to design landfills. And they said, you're going to actually work on this project in Dublin called district heating, and it's to do with the waste to energy plant. So did that for 4 years, and then moved to Denmark. And within a month of moving to Copenhagen, I was sent to Kiev, and I was working on district heating systems throughout Eastern Europe. That was the start of it. EPRD, EIB, EU projects to rehabilitate district heating systems. So the Soviet Union had district heating as its supply of heat. So centrally designed, every city was pretty much the same energy centre, and then pipes going out to the different apartment blocks. All the apartment blocks look the same. If you fly over an Eastern European city, you'll notice the buildings from the sky. You can tell which is a hospital, which is a school, where the apartment blocks. It was really a massive central design. So we were sent in to do feasibility studies and then design and build tenders for rehabilitation of existing systems and to try and improve those systems. So I worked in Kazakhstan and Ukraine and Belarus, did some work in Croatia. So a lot of different experiences from that. And then I was in the US to work on decarbonisation projects. So they have a lot of steam systems in the US, from army campuses, university campuses, pharmaceutical campuses, and they were looking to decarbonise their sites. And when we were putting in hot water systems over there, and how you could decarbonise their thermal generation that way. And then I spent a few years working in the British government. I was seconded there on the heat zoning project, which is going to be legislation next year, where they're looking to identify zones of the country, and if you're within that district heating zone, you're mandated to connect to the district heating system once it's built, and your energy consumption is over a certain level. So they plan to decarbonise 18% of their heat demand that way. And then my last stint before Yuno was with Novo Nordisk, and I was project manager for a €300 million decarbonisation project of a campus there with 9 factories and a 59 megawatt energy demand. So we interconnected 9 factories with district heating and cooling piping, and shared heat between the factories. And then we put in a 132 kV high voltage connection to supply the new heat pumps. So we had 3 heat pumps generating heating and cooling simultaneously and connected to the network. So it's pretty advanced in terms of the investment that the company wanted to make, and they had lots of money last year. This year they have a little less money. So what is district heating? There's 3 main components. You've got your heat source, and that can be variable. You can have electric boilers, you could have industrial heat pumps, and I suppose that's the flexibility of it, that anything can be connected to a district heating system and provide heat. In the Danish system went from coal-fired to CHPs, to gas CHPs, to waste-to-energy plants in the 90s. Now they're putting wind and PV via electric boilers and heat pumps into the district heating system. So it can take multiple sources, and it's the pipes, it's a delivery system. It just moves the heat. So we have a gas system today that distributes fuel that we can use to heat our homes. So this is a somewhat easier way to deliver heat to homes, and people don't have to say, "Oh, I have to buy a heat pump which costs 15,000 euros." I can just have a utility contract like my ESB or my Irish Water contract and have heat. And because it's centrally supplied, it's more efficient, it's maintained. Heat pumps are not always maintained the way they're supposed to be or operated the way they're supposed to be. So this is somewhere where you have a heat source that's variable. So then the next part is the network, which is really the costly part of a district heating, like all, I suppose, infrastructure, utility infrastructure. It's expensive to dig up the roads and plan it and get the space and get the planning. You have different types of district heating piping. You have steel, pre-insulated piping, you've got plastic piping, you've got twin pipes, so that can vary. And then your demand could be residential, commercial, industrial. So you can have very high temperature district heating. You can have low temperature district heating, and you can boost it at the source for industrial use. So what else did I want to cover here? Yeah, so that is district heating at a high level. But why is district heating important in Ireland, and why is it being used across Europe? So there's a lot of points here. Energy efficiency has environmental benefits, cost savings. It can provide energy security and resilience because we're using locally produced heat and we're bringing it to homes rather than importing fossil fuels. And then it allows flexibility and scaling. But I suppose you'll get the slide decks after the talk, but these are kind of the 2 areas I'd like to look at a bit more. Is where does district heating support the electric grid, and how does it utilize local energy sources, and how is it beneficial from that perspective? So district heating can utilize local energy sources, as I've said, including waste heat from industry and other sectors. So integrating of electricity, heating, cooling, and transport, the demand and supply sides, is called sector coupling. It's a phrase that's used an awful lot in Denmark, and I have heard it here since I've come back. And it's a key strategy to achieving low carbon and integrated energy system and meet a growing energy demand. So you're looking at where can you share benefits between energy generation and supply. But it also provides the opportunity for innovative business models and consumer choices. I'll go into that a little bit. The photograph is from Sand in West Denmark, and that system is a combination of a district heating system that brings in solar thermal, wind power, and a heat pump, and has storage. And it's quite an integrated system to deliver heat. I'll go through a couple of more examples of sector coupling. So this is a district cooling example on the left for Copenhagen Harbour. So this has water pipes connecting the sea outside. That's actually the sea there coming in into the harbour in Copenhagen. And it's all underground, and it generates the cooling for hotels, commercial premises in a small area of Copenhagen. And it's interesting because they didn't have district cooling 15 years ago. District cooling was something that they started to identify as a need It's not regulated in the same way as heat is, and it's not a non-for-profit business. It's a commercial enterprise. So it's based on them being able to sell cooling to commercial premises that see a benefit in taking it on, and a commercial benefit, but also a financial one. So they're able to take cooling from the sea and pump it to hotels and offices in the downtown Copenhagen area. So the hotels noticed that they could take their cooling equipment from the rooftops and make gardens up there and places to have beer gardens, things like that. But then they could also get efficiency because it was at 80% efficient, the system, in terms of cooling using the cooling water from the water. And it's something that I suppose when I look at Cork, that kind of system where you're taking heat from the river in Cork and taking it to the docklands could definitely be something that's explored further. The example on the right is a wastewater treatment plant in Odense. It's not called a wastewater treatment plant, though. It's called a resource recovery facility because it makes electricity, heat, and biosolids. And those revenue streams, the 3 revenue streams in this wastewater treatment plant, support the operation and maintenance of the plant, but also make the biosolid production a viable a product, because it costs more to make it and to sell it. So it's, when I saw that facility, I really thought, if the district heating system wasn't there for the wastewater treatment plant to connect to, they couldn't sell the heat, they couldn't get that revenue stream, and they wouldn't have been able to do the biosolids. We do electricity in Ireland, in Irish Water do that. They make electricity. If they have it, they put it in the grid, and they use some of the heat in their wastewater treatment plants, but they don't get any revenue from that. But it's just I saw lots of examples in Denmark where if the district heating system was there, they could avail of it and use it to generate another revenue stream of something that hadn't been thought of before. So it has multiple uses, I suppose, is the takeaway there. Sector coupling. So this is a project in Turnbu, and it's super interesting again because there was no district heating in this area by the airport, and there was a wastewater treatment plant, and then there was a new area that was newly zoned for commercial premises. They put an aquarium there, a few things, but it was quite an industrial area previously, and there was an idea to use the heat from the wastewater treatment plant. And then, so they put in a heat pump and they send the heat to the district heating system that supplies the hotels and the industrial park. And then they take the cooling out of the other side of the heat pump and they send it in the cooling network to the commercial premises. So they're simultaneously producing heat and cooling, and they're using both sides of the heat pump. So it makes it very efficient. And then they have an ATIS, which is an aquifer thermal energy storage system. So that park area is covered in boreholes, and in the summertime, they're generating the cooling, and the heat is coming out of the other side of the heat pump, and they pump it into the ground. And then in the wintertime, then they take that heat out, and they've excess cooling. It goes back in to recharge the ATIS. So the ATIS operates like an aquifer, an enclosed aquifer storing the heat. And the heat pump uses that to keep an efficient system. So yeah, it's not, I suppose the thing I want to note from this as we look in Ireland to develop district heating projects is this is really impressive. It's talked about a lot in Denmark. It's not huge. Okay, it's nearly 5-6 megawatts, but it needed a few key anchor tenants to make it work. And then they're building on it. There's plans for second phases. And, within a few kilometers is the Copenhagen district heating system, but they're not right beside it. Sector coupling, again, data centers. This is obviously something that we have a lot of in Ireland, and it provides a potential opportunity. One of the first data centers in the world was this one in Odense. And it was very innovative at the time. Now there's a few more, there's not a lot more, but it's quite a big system. But we have our own now in Tala. The Tala district heating system, which takes waste heat from Amazon and takes it and delivers it to South County Dublin's offices and the university and an apartment block now, most recently. But it has potential to scale as well, to put in more components and to build on it. And that, I suppose, is a good template for us to look at and to say, okay, this is something maybe we could build on. I think I read today there's 82 data centers in Ireland. I know there's 67 around the M50. the electrical demand of a data center is equivalent to the thermal output. So if you think about these things are monsters. I didn't really know a whole lot about data centers before I came home to Ireland, but they have a huge electrical demand, and I suppose that's what we hear about on the radio all the time. But the output is just put into the air. So that's why a lot of the planning conditions are for district heating to be connected to them if a district heating system exists. But it is something that if we continue to have data centers, and we already have quite a lot, it's something that could be used to replace natural gas and be like the Danes use waste to energy plants to fuel a lot of their district heating in the 90s. And it could be something that we look at and say, okay, this is a tool or a benefit that we have, and we should use that to decarbonise our heat. And how do we best access that and use it? But at least we have a template of something that's been done already in the Talis system, and it's to replicate that and interconnect them. Renewables. This is something also that can benefit significantly from district heating. And we're talking about district heating at scale, but hot water can be stored very cheaply. This is a picture on the right of a large thermal energy storage tank. Think of them like very large thermoses, and that's what they are. But they store thousands of litres of water, and you can have 8 to 15 hours storage in your tanks for a city. So those two very large ones near the office I worked in Copenhagen, and you could see them from a distance, but they could supply half of the city with water for heating with the water for quite a period of time. Then you have, I suppose, with this potential to store water, store hot water, you can reduce curtailment of renewables. So if there's excess wind or solar, as we are more than likely going to get as we integrate more into the system, you can store it in the thermal system and then use it to generate heat and reduce the peak electrical demand and offset that generation that's needed at that time. And today, I suppose what I see is that when we get to peak generation in the wintertime, we still use Money Point, and we use the coal that goes into Money Point. And what, as we get more, let's say it's data centers, or we get more electric vehicles, or we get more heat pumps, which is the target, we need more electricity. We are getting more turbines, but we're still at peaks going to be using Money Point in the near future. And that's where we have to start to think differently about our whole energy system and where can we move the energy demand. And district heating is a tool that allows for that. And it's shown here, I suppose, the days of district heating, wind and solar. This is one of the slides that's a bit detailed, and if there's something I really want you to take away from today's talk, it's this. So we spend a bit of time just to look at this. So this graph is taken from EirGrid's website, well, from the data on their website, the one on the left, and it shows the dispatch down is the light green curve, and then the top one is capacity of wind being installed, the yellow curve, yellow line. And so you can see as we increase capacity of wind being installed, we're also having further dispatch down, which is curtailment. And when we have curtailment, it ends up being an additional cost paid by consumers. And we have the highest electricity price in Europe at the moment. So, and at the bottom underneath that graph is the imperfections charges that EirGrid have last year and forecast for this year. So you can see 592 million is 24-25, and imperfections charges is it's the line on the bill that it's for balancing the grid in real time. So they sometimes can't predict that. So it can be quite costly. And next year it's forecast to be 3.5 cents per kilowatt hour on our bills. So just to kind of break it down to what you see, I think I'm paying 30 cents at the moment per kilowatt hour. So it'll be 33.5 cents next year because of this. But there's other charges I know are coming in addition to that. So then on the right, we have the Danish district heating system. Now they have 600 district heating systems across the country, similar population to Ireland. So similar challenges. They have a lot of wind as well, and they're figuring out how to integrate it. So the district heating system gives a lot of flexibility to them, because it's the largest electricity consumer and it's the largest flexible one. And they've got electric boilers and industrial heat pumps, and they've got thermal energy storage, and they've got pit thermal energy storage, which is a seasonal storage where you fill a cavern basically, and you keep it from one season to the next. And when they are, the graph, I suppose, at the bottom to look at it, you've got generation and consumption shown. So the solar is in yellow, and that's the solar generation, and the wind is green, and the spot price is indicated by the dots. And there's quite a low electricity price there because there's a high wind and solar generation. And then the red shows the consumption by the district heating system, picking up that electricity at a low cost and making heat and bringing it to the homes. So the Energinet, which is the air grid equivalent, they're able to use that existing infrastructure. They're not paying for more batteries to take this energy. They're able to actually give it to existing heat networks to use it, and their spend, although they're probably different to some degree, but the spend is 270 to 300 million. And if you compare that to the 592, it's half the cost. So some of that is the type of ancillary services that they're using there to balance their grid. And one of the things I suppose you could see is that it's a much more efficient use. Instead of having conversion losses to a battery, you're able to turn it into thermal energy, and especially with the use of a heat pump, very efficient, send it to a home, instead of storing it in maybe an electric battery or somewhere else. So this is at scale, is a very useful system to curtail energy, store it, and use it when you need it. And this is another example to take as well in terms of balancing services that it can add. So these are ancillary services when you've got noise on the grid or some disturbance where there's more generation or more demand than expected. They employ ancillary services at an air grid level to help filter the noise, restore the frequency, and stabilize the grid. So there's very, very fast millisecond response times required for that. And the Danes use the electric boilers connected to the district heating system to do that. And the chart on the right just shows kind of the planning that the West Denmark, where it has an awful lot of wind, there's two grids, west and east, and this is the west grid. And they are planning to use electric boilers, which have a very fast response time. Heat pumps also have a very fast response time. And the benefit here is that they're a centralized customer that you can say switch off, switch down. It's not like if you have a heat pump at every home, they don't have control over that. So I suppose that's a strong benefit in terms of an infrastructure that's there. So you're not paying more for it. I've worked on some projects where they're developing ancillary services, innovation approaches just for this market. But what the Danes already have is they have a heat market that's decarbonising their heat, and they can use it to balance their grid. So the costs are lower. So, yeah. Then I want to talk a little bit about who else is using district heating to decarbonise heat. And that, I suppose, we in Ireland, I'll talk a bit about what we're doing, but this also gives a perspective as to why district heating is been looked at differently across Europe at the moment. This is Greater Manchester. In the UK, they're planning this, or in England, they're planning heat network zoning legislation, and they've been working on it since 2021. And it's impressive when I worked there how much work has gone into it and money to develop it, but their population is so big, and how this will impact their cities and infrastructure and the money required to do it. They have to put a lot of work in to make sure it works well. But they developed their own software to try and figure out where should the 18% of district heating go in the UK. And this is an output from the model. It shows Greater Manchester, which is a monster city, 2.8 million. 4.65 gigawatt hours per year is what could be connected to district heating there. So when you look at our targets for 2030 are half that, roughly. So if we had connected Greater Manchester, it would cover us quite well in terms of our heat supply targets. But the zoning legislation, as I mentioned before, when it's in place, the idea is that if you're in a mandated area and you have over 100,000 megawatt hour demand per annum, you're mandated to connect. And that will, when you look at the viability of a district heating system, you have to have your heat source, you have to have your network, and you have to have someone to take the heat. And by the consumer risk is always there, that you don't know whether they'll actually take the heat until you knock on their door and say, well, we've built the pipe, would you like some heat? So the English are trying to remove that by mandating that connection. So you have a revenue stream once you've built your district heating system. This is a heat pump plant in Queen's Quay in Scotland. And it's also on the Clyde River, and they've put in a heat pump and they supply, I think they've 2.65 megawatt heat pumps there, water source heat pumps. They have thermal storage, and they supply 51,000 megawatt hours of heat demand. So they've been doing that project since 2021, but they did that in absence of legislation because they had their Heat Network Act came in 2021, but the Scots have been quite progressive in developing district heating and using it and trying to figure out where they could use it. The secondary legislation, so they have a legal framework in terms of the regulation, licensing, and how to zone heat networks. Now, the secondary legislation is going to come in this year, apparently. But it's built, and it's a very nice looking building, as you can see there. But it was quite a pioneering project, putting in a heat pump at the Clyde. So then I would like to talk a little bit about Ireland's plans. In 2022, SEI did a heating and cooling study, quite a comprehensive study with multiple reports. And it identified that there's excessive dependence on fossil fuels in Ireland. And then there's also an urgency to deliver climate targets using available technology, that we should move ahead as quick as we can. District heating and heat pumps could play a vital role in Ireland decarbonising fast. And then I suppose one of the biggest takeaways was that over 50% of Ireland's heat demand could be supplied by district heating. And then we have these targets also that are in the background. So we've got the Renewable Energy Directive 3 has binding EU targets. So we have, and that's for renewable heat. So we've got 6.3% of our heat is renewable today, and it's to be 16.1 by 2030. So we have a large jump there to make. And then we have our own individual district heating targets that we've set in the Climate Act. And that's 2.7 terawatt hours for 2030. And that, when you look at that, that's about 390 Tala projects or 24 pool bank projects. So it's probably not going to happen. We'd have to say that. And then the Climate Action Plan has a 24% renewable energy share of heat target. And so that's more ambitious than the 16.1 that is legally binding. But we are making progress. So SEI established the Centre of Excellence in 2024. And this is to provide assistance to develop district heating for the public, private and semi-state sectors and encourage district heating and promote it. And they are being well resourced, and they are progressing, and it's great to see that. In terms of timeline and how things are progressing, I suppose there was a draft heat bill in November last year, and then the programme for government called out that the government would enact legislation in 25 to accelerate the rollout of district heating systems. So they've put this target in front of them for this year to really get that draft heads of bill into legislation. In June, it went for public consultation, closed in July. In July 17th, they announced that they would have €5 million for developing projects to be shovel ready. So this is the first time they've really kind of said we're going to fund district heating in some significant way and put money towards development of projects. And then the National Development Plan has I think it's 500 million to fund projects to mitigate climate change, and district heating is one of those. Offshore wind is one of those, and the exact pot for district heating is set to be announced, but it hasn't been announced yet. But they will hopefully fund district heating projects and make, I suppose it's the funding of the sector that is really needed to develop it further and at speed. So, as I mentioned, I suppose there's a few takeaways I'd really like to embed in your mind before you leave, and I suppose that's that district heating is a least cost tool to decarbonise our energy system. And that's, in terms of as we get more renewables onto the grid, district heating is a tool that I've seen in Denmark that they use to balance the grid, to avoid curtailment, to avoid dispatch down, and to use the energy for supplying decarbonised heat to homes and industry. And it's a delivery system to replace other forms of heat delivery at scale. So when we try and convert everybody to heat pumps, maybe not everyone's going to have the capital or the ability to fit a heat pump into their home. But district heating would be a utility that can go by your home, especially in urban areas, and then you can connect it. HIU unit, which is what you need to connect to a district heating system, is quite small and can fit easily in a cupboard. And I suppose the final point is about sector coupling. And I've given some examples today of what is that and how does it work and what are the potential benefits. So when we look at district heating and we say, okay, well, it's the same as heat pumps, it's just another choice, it actually has a lot more benefits to society and how we could develop our decarbonised energy system. So thank you. Happy to take any questions.